All right, let's now learn how to use the estimators, especially to find the values of beta 1 and beta naught. So given the following data set, so you've seen that the data that you're given is of height and weight. Okay, the data that you're given is of height and weight. We have the height here in centimeters. This is the height and weight. So you want to look at the relationship that exists between height and weight. Okay, 1.64 is the x variable, whereas 63 is the y variable. You know, the data is presented in coordinate form, x, comma, y. Okay, so just know that the first one is the value of x, then the later one is the value of y. Just understand that you can still rely this data in horizontal form, like you can put it horizontal like that. The values of x can still be 1.64, 1.86, 1.82, 1.75, and 1.67. Then you can put the values of y here down. 63, 72, 88, 78, and 67. Okay, so even this way is another way of presenting the same data. Still, you can present the data in column form. Okay, in the column format where you put the values of x here down and the values of y here down. So these are the three common ways on how usually these data are presented. Okay, so what do we do now from here? We know that to find the value of beta 1 it is equal to n, the summation of x, y, minus the summation of x, the summation of y, all over n, the summation of x squared minus you open the bracket, summation of x, right? Then you square that. This will give us beta 1. And when we have beta 1, you can easily find the beta naught, right? Beta naught, which shall be equal to y bar minus beta 1 x bar. And then from there, you can easily find the estimate. Is that clear?
Yes.
And you can easily predict later. So let's find the value of beta 1. Now I want to show you something that is very important. Okay, so hoping that the class is being recorded. Okay. Something that is of greater importance that we have to understand is that okay, something of greater importance we have to understand is that you need the value of n, right? You need the value of what? xy, isn't it? You also
Yeah.
need the summation of x. You need the summation of y. You need the summation of x squared. You need the summation of x values. Is that clear?
Yes.
So what we are going to do from here, I'll present this data in a table form so that you can come up with these values, these parameters: summation of xy, summation of x, summation of y, summation of x squared, and summation of x. Okay. So let's start with the value of x, then and the value of y. Okay. I've put it in a table form. The value of x is 1.64. The other one is 1.86. 1.82 and 1.75. Then we have 1.67. Is that clear?
Yes.
The corresponding values of y is 63.72. I'm hoping that you have calculators where you are. Yeah, higher is the chance that people might be in brackets, but I'll need you to calculate so that we can move a little bit faster. Okay. You've seen. So I've changed the format of the data, so it's now vertical like that. It's in column form. Is that clear?
Yes, it is.
Beta 1 is equal to n, the summation of xy minus the summation of y, summation of x over n, the summation of x squared minus the summation of x, then we square that. So I want you to be seeing from the formula what we need. So we need to sum up the values of x. We also need to sum up the values of y. Then from there, we need to find the x squared. I think we need to find the x squared. We need to find the x squared. We need to find the x squared. So how do we find the x squared? We need to square these values of what? The values of x, right? Let's create a column for x squared, right? Start squaring for me. What is 1.64 squared? These are x values, just
2.56.
2.56. Let's not miss, make sure in your estimations, what you're giving us is okay. So 1.64 squared. I find the 2.69. You can try it again.
Which one?
1.64 squared.
It's 2.69.
Yes, 2.69. Very, very important.
Okay. Yeah, 2.69.
Then what is 1.86 squared?
3.46.
Okay. Square that. 3.46. 3.46. What about 1.80?
3.31.
3.31.
31.
What about 1.75? 1.75 squared.
3.06.
3.06. 3.06. What about 1.67 squared?
2.79.
2.79. Okay. Then from here, what do you need from our formula? We can easily find the summation of x, summation of y, summation of x squared. We need the summation of xy, isn't it? We need the xy. So we need the column for xy. Is that clear? Just getting this from the formula. So what xy means, it means that you multiply the x variable times the y variable, the dependent times the independent variable. And what do you get? 1.64 times 63.
103.2.32.
103.32.
32.
Onyambe, are you finding the same?
Yes, I am.
Okay. What about to the next one?
133.92.
1.33.92.
Yeah, 0.92.
Next.
137.16.
137.2
16
or 167.
160.16.
160.16. What about the other one?
136.5.
136.5. What about the next one?
111.
111.89.
0.89.
Easy? Is it difficult? Very easy, right? Madam Mlenga, we are fine?
Yes, it's okay.
So let's sum. You can see that we can easily now get all these values that we have here. We don't know how to find any, just count these sets, how many they are. The corresponding coordinates. There are how many? So you have 1, 2, 3, 4, and 5, right? Is that clear?
Yes.
Hmm. So we need the summation. Let's sum up. Let's sum them. The summation of x, you add all these x variables. Just add the x variables, give us the number there, what you find. We are examining the relationship between what? The weight and height, okay? Especially that the height is an independent variable influencing the weight, okay? Let's see the relationship between height. We're just researching this relationship and let's see what happens, how related they are. We interpret the units later on, the estimates. And what do you find? Hello, what do you find when you sum up the x variables?
18.47.
18. When you add 1.64 plus 1.86 plus 1.82 plus 1.75 plus 1.67.
I think I messed out the point on one of the values.
I guess so.
So 8.78.
8.7. Okay.
7.8.
You find 7.8. I find 7.4. I find 7.4.
Oh. Let me try it again.
Madam Nyambe, you can be summing up the Y variables.
Okay.
Okay. Yeah. 7.2.
Okay. All right. So what do we have as the Y variables?
Let's see. 368.
Okay. Are you finding the same, madam?
368.
Okay. 368. 368. Sum up the x squared now. Get the summation of x squared.
$15.29.
15.29. 15.29.
Yes.
Okay, let's sum the xy. Can you quickly sum the xy?
$652.79.
It is
652.79.
0.79. Can you repeat again? Try to do it again.
Six 645.9.79.
Yes, 645.79. 645.79. Okay. So from here, we are done collecting what we need to put into our formula. So let's start now putting into our formula. We need the value of n. We said our n is what? 5 times what is the xy? 645.79 minus the summation of y, which you said is 368, multiplied by the summation of x, which is 8.7, right? All over 5 times the summation of x squared, said it is 15.29 squared minus the summation of x, which is 8.7, then you square that. Let's find the beta 1. I think you've seen how we are replacing into our formula, right? Very easy. Very, very easy. You can punch your calculator. What do you find on top? 5, you open the bracket. 645.79 close minus 368 close, you open, you have 8.7. What do you find on top? Okay, I find 27.35. Someone to confirm?
Yes.
Steps 15.29. Oh, you don't square this one. This one is not squared because the 15.29 is already squared. You get it, right? You don't square it again because the formula is n summation of x squared, not squaring the summation, right? So 5 times that minus 8.7, then you square the value of x. And what do you get as the denominator? What do you find? People, you have stopped calculating.
Yeah.
Yeah, you command your calculator the way how it appears here down. 5, open the bracket, 15.29, you close minus 8.7, then you square. Okay.
0.76.
0.76. Okay. Then divide now. What is the value of beta 1?
$55.99.
So 27.35
35.
divided by 0.76. It is 35.99.
0.99.
Okay. Yeah. So that is that. Okay. So you find your beta 1. What about beta naught? For you to find the beta naught, you need the y bar minus beta 1 times x bar, meaning you should find the means of x and the mean of y. So to find the mean of x, you just do the summation of x divided by n, right? The summation of x is 8.7 divided by 5. What is the summation of n?
It's 5.
It is what?
Summation of n. It's 5. 5.
What do you find as the mean? I mean the
Oh,
mean
okay.
when you do summation of n divided by n.
Oh, okay.
1.74.
1.74 as the x bar, right? What about y bar?
Yeah, 73.6. Hello?
Sorry?
73.6.
73.6. So 68 divided by 5, 368. 368 divided by 5, 73.6. Yes, that's our y bar. It's our y bar. So it is 73.6 minus our beta 1. You say this what? 35 point what?
99.
0.99 times the x bar is 1.74. Just multiply to find our beta 1. Or our beta naught, sorry. What is our beta naught?
$10.977.
It's what?
10.
10.9.
10.977.
9774.
Okay, so you can put 98, right? As a beta knot, right? So you can now estimate the line. You can easily estimate the line, and the estimation of your line will be y, okay, is equal to beta naught is 10 point what? 10.998
8.
plus beta 1 is what? What was our beta 1? 35.99.
Yes.
X plus the error term. Is that clear?
Yes.
Yeah. So that's what is there. So the dependent variable here, it is y, which is the kgs, right? The weight. So assuming that x is 0, meaning the weight and the height, assuming that the height is 0, such things don't exist. Assuming that there is 0 height, then you have the value of y remaining at about 10.98 units. Okay, and these units are measured in kilograms. That's weight, right? Yes. Then for when there's 1 unit change in x, of which our x is say the x is the weight, is the what? It's the height. When there is 1 unit change in height, then the weight, which is our y, changes by 3,599 units. Is that clear?
Yes.
Yeah. That's how you interpret the beta naught and beta 1. So the beta naught is actually the change in y when x is 0. So the change in the weight when the height is 0. And this one will be the change in y when x, which is our height, changes by a unit. Is that clear? Hello?
Yes, it is.
Yes. So if that is clear, then it is well. Learned how to estimate the regression line. It is possible to use again that other formula, right? That other approach. We can use the second approach. Let me just recording this.